All right, in this video, let's prove this theorem. If n is odd, if and only if n squared is odd. Proof. Okay, it's an if and only if, so I have to go two directions. So let's assume first that n is odd. By definition, there is an integer k so that n is equal to 2k plus 1. That's the definition of what an odd number is. So let's take a look at what n squared is, knowing this. N squared is equal to 2k plus 1 squared, and that's equal to 4k squared plus 4k plus 1. Now on the first two terms, let's factor a 2 out. You get 2k squared plus 2k plus 1. Now that's a bit unusual, just factoring only the first two terms. Also, I only factored 2 out as opposed to 4k, which I could have factored out. I only factored a 2 out because this now fits the form of an odd number. 2 times something plus 1. By the axioms of arithmetic, (2k squared plus 2k is an integer. In other words, k is an integer, so 2 times k is an integer. K is an integer, so k squared is an integer, and 2k squared is an integer. And if both of those are integers, then the sum is an integer. Therefore, n squared is odd by definition of odd. Okay, so that's the first proof. Now this is a blue light special, if and only if, so it's 2 for the price of 1, and I have to also go the other direction. So to go the other direction, if I were to try a direct proof, I'd start if n squared is odd, then n is odd. I will do the contrapositive of that instead. Instead of showing that if n squared is odd, then n is odd, I will instead show that if n is even, then n squared is even. So we're going to do this by contrapositive. So assume that n is even. By definition, there is an integer k so that n is equal to 2k. Now let's see what n squared is. Therefore, n squared is equal to 2k quantity squared, which is 4 times k squared, and I can factor a 2 out of that, so 2 times 2k squared. Okay, by the axioms of arithmetic again, (2k squared) is an integer. Therefore, n squared is even by definition of even. And so let's summarize what we've just established. Therefore, if n is even, then n squared is even. And the contrapositive of this would be that if n squared is odd, then n is odd, which is what we wish to prove. And so we've done both directions, and so that ends the proof.